Hi, on this video I'm going to talk about the two popular terms called covariance and correlation. So first let's look at what do we mean by covariance and how do we calculate covariance. So covariance basically helps us to calculate the linear relationship between two variables. So let's assume, for example, we have two stocks, stock X and stock Y, and we want to understand is there any sort of linear relationship between these two stocks. In other words, if the price of stock X increases, what's going to happen to stock Y? And if the price of stock X decreases, how will the price of stock Y behave? So you can see here by looking at the diagram, as stock X increases, you can see generally the price of stock Y is also increasing. So we can measure this relationship by calculating the covariance between stock X and Y. So here the covariance between X and Y is simply we sum the values of X compared to its average. So mu X is the mean of X. So let's assume, for example, you have 30 observations. So you have 30 values of stock X, and for the same dates you have 30 values of stock Y. So basically what you do is you calculate for each day, you calculate the value of X compared to its average, and then for each date you calculate the value of Y compared to its average, and then you multiply those for each date, and then you divide it by the number of observations. So in this case, if we have 30 days, we divide it by 30. Now I will show you later how you can calculate this in Excel. Now one of the issues with covariance is that covariance doesn't tell you much about how good is X and Y correlated to each other. In other words, the covariance only tells you one thing. It tells you whether the relationship is positive or it's negative. Now what does that mean? If the covariance is a positive number, so let's say in this case we got this as 150. So if it's a positive number, what that means is if stock X increases, stock Y will also increase. If stock X decreases, stock Y will also decrease. Now if it's a negative number, for example, if we get minus 150, what that tells us is that if stock X increases, stock Y will decrease, or if stock X increases, stock Y will decrease. In other words, they will move in opposite directions. But the issue with covariance is that it does not tell us how strong is the linear relationship. In other words, let's assume that you calculate the covariance between two stocks as 10,000. So that's one answer. And then you have another two stocks and you calculate the covariance between those two stocks as 285. Now you might be thinking the one which has a higher covariance suggests that those two stocks will have a strong relationship, but that's not true. So just having a higher number doesn't tell us anything about the strength of the linear relationship. So that's one of the biggest issues with covariance. Now the reason for this is covariance is always measured in units. So remember that covariance is always measured in units. So what that means is that just because you get a higher number doesn't mean these two variables have a better covariance or a better linear relationship compared to these two variables, just because it has a higher covariance, because covariance is measured in units. So it's just a matter of these two variables might have a higher unit compared to these two numbers. So what do I mean by that is, let's assume you had two stocks here, and these two stocks are the current market price of these two stocks. Let's assume it's like $10 and $12. So average is $10 and $12. So they move, these two stocks can be $8, $9, etc. And these stock can be $13, $16, $80, $20, etc. But these two stocks, let's assume that their prices are 101 and just the average price, and 250. I'm just kind of randomly selecting. So you can see, just because this has a higher number doesn't mean these two stocks are close, have a better linear relationship than these two stocks, just because you can see the units are much higher. The prices are much higher for these two stocks compared to these two stocks. So just having a higher covariance does not imply that those two variables have a better linear relationship. So this is where correlation comes into play. Now, correlation, the formula for correlation is simply covariance. So in this case, let's assume between x and y. So covariance between x and y, and then we divide that by the standard deviation. So I'm just writing in shortened form, standard deviation of x and standard deviation of y. So that's correlation. Now, the beautiful thing about correlation is always between -1 and +1. So if the correlation is closer to +1, that means both variables have a very strong positive linear relationship. In other words, if x increases, y also will increase, and the proportion of increase will be very close if it's closer to positive +1. Now, if it's closer to negative -1, what that means is they have a very close negative relationship. So in other words, if variable x increases, let's say by about 10%, variable y will decrease by around 10% if the correlation is -1. But if it's closer to -1, it has a strong negative correlation. So correlation is a stronger parameter to measure the linear relationship than covariance. Now, the simple reason being, it does not depend on units. So for example, in this case, the correlation of 1 could be 0.8, and the correlation between these two variables could be 0.9. So now you can clearly say that these two variables are more strongly correlated compared to these two variables. So correlation is a better parameter to estimate the linear relationship of two variables. Now, one other thing it's worth mentioning, there's an element. Now, one other thing worth mentioning, when we talk about two variables as independent, what that means is, if we say x and y are independent, having information of x will not help you to predict y, and having information of y will not help you to predict what happens to x. Now, if we say that two variables are independent, then what that implies is that the covariance and correlation of those two variables will be 0. So remember, if two variables are independent, then the covariance and correlation of those two variables are 0. But just because the covariance and correlation of two variables are 0, that does not imply, so let's assume the covariance between and correlation between two variables A and B. If we say that the covariance and correlation between two variables are 0, that does not imply that A, B are independent. So remember that if two variables are independent, then definitely their covariance and correlation is 0. But on the other hand, if we have two variables and we calculate those variables covariance and correlation as 0, that does not imply those two variables are independent. Now the reason for this is, remember, covariance and correlation only gives us information about the linear relationship. So A and B could be non-linearly related. So that's the reason A and B could have a 0 covariance, which means of course it has a 0 correlation, but it could be still dependent on each other. So remember, that's an important concept to remember. Now another point, when we calculated this here, what we said was this formula here for covariance, this formula here, when we said we divide by n, we were talking about the population covariance. Now remember, in real world, so remember, when we say population, you have a population here. For example, let's assume that stock X and Y has been in the market for the last 10 years. Now, in reality, if you want to calculate the covariance between these two stocks, you're not going to have 10 years worth of data. It's very rare. Sometimes you might have it, but most of the time you will not have the whole population. So most of the time what you will do is you will select a particular sample, maybe last 1 year's data or last 2 years data. For example, you will select a particular sample. Now when we calculate the sample covariance, instead of dividing it by n, you divide it by n minus 1. So that's something to remember. When you talk about sample covariance, instead of dividing it by the number of observations, you divide it by number of observations minus 1. And at the same time, when we calculate the correlation, the sample correlation, so this will be sample covariance. And then instead of the standard deviations of the population, you will use the sample standard deviations. And remember, the correlation will not change between the population and the sample. That's because n minus 1 gets cancelled when we use the standard deviations. Because remember, the formulas for standard deviations for the population and for the sample is different. And because of that, the correlation, the sample correlation and the population correlation will not change. So for example, if your population correlation is 0.8, your sample correlation also will be 0.8. But of course your covariance will change. It will slightly increase. Your sample covariance will slightly increase because you're dividing it by a slightly smaller number. So remember that there's a slight difference between population covariance and sample covariance. So here I've calculated the covariance and correlation between stock A and stock B using Excel. So you can see here, these are the individual values of stock A and stock B. And what I've done here is I've basically calculated A minus mean of A minus multiplied by B minus mean of B. You can see here. So what I've done is, you can see here, I've taken the value of stock A and then I have deducted it from the average of stock A, that's the mean, and then I'm multiplying it by stock B minus the mean of stock B. So I calculate the value for all the observations, and then finally I sum them. I sum all of them and I divide it by 21 because we have 21 observations. So that gives us 745.47, and that's the covariance, 745.47. And for the correlation, you simply divide it by the standard deviations. And in Excel, you can use a formula called correlation here, which gives you the sample, the population correlation and the sample correlation. Now, one thing to remember, in Excel, you have only one formula called covariance, which calculates the population covariance. So if you want to calculate the sample covariance, you need to multiply this number by the number of observations and then divide it by n minus 1. So remember, what Excel gives you as this formula here, is the population covariance. In other words, Excel has divided it by n, not n minus 1. So if you want to calculate the sample covariance, you need to multiply this number by n, which is the number of observations. So in our case, it's 21. And then you divide it by n minus 1, which is 20. So remember that this formula here only gives you the population covariance. So that's something to remember. Now, there's no problem with correlation. Remember, the correlation doesn't change between the population and sample. So you have no issues there. So that's something to remember. And if you have any questions, just post a comment or send us an email, or you can also ask the question in our forum and I can have a look. Thank you.